Hi everyone, this is Robert Hodges, and I will be your host today at our Altinity webinar on adding fast analytics to MySQL applications with ClickHouse. Before we get going on our webinar, I'd like to just bring to your attention a few features about the Zoom webinar software we're using. The first thing is that Zoom allows us to record this webinar, so we'll be publishing both the webinar recording as well as the slides afterwards. You should get a link in email, which will allow you to rerun the webinar as well as look at the slides. Second, we will be taking questions and answers and giving answers. This webinar is not super long, so we'll have plenty of time to answer questions at the end. If you'd like to pose a question, just pop up the Q&A box and type your question in. If it's something relevant to what I'm speaking about, I may answer it on the way. Otherwise, we'll wait till the end of the webinar. And then finally, speaking of the end of the webinar, we will be running a little poll at the end, just asking how the webinar went, what other topics that you would like to hear about. We'd appreciate if you would fill that out, because it enables us to gauge what people's interests are and pick topics that will be especially useful to our listeners. With that, I'd like to go ahead and get started. So just a little bit about my background. I'm the CEO of Altinity. So I run the business, but the fun part of my day is actually doing presentations on technical topics. I've been working on databases since 1983, starting with a database called M204, and have been through a number of different roles that have allowed me to work with many, many databases. ClickHouse is the 20th database I've worked with. Altinity is the leading software and services provider for ClickHouse. You can think of us as the enterprise ClickHouse company. We are the #2 committer to ClickHouse, and we're also a major community sponsor in both the United States as well as Western Europe. So if you have the chance to attend ClickHouse ClickHouse meetups, for example, there's a very good chance that that's something that we sponsored. With that, I'd like to go in and dive into the topic at hand. So for those of you that are not familiar with ClickHouse, or for whom this is the first time you're encountering it, let me give you a quick introduction. A very simple way of explaining how what ClickHouse is just to imagine that MySQL, a popular open source database, and Vertica, a very powerful data warehouse, got married and had a baby. That baby would be ClickHouse. And from the MySQL side, we get the fact that it's portable, relatively easy to manage, and open source, so it's easy to adopt without having to pay license fees or talk to a salesperson or anything like that. From the ClickHouse side, we get parallel query, vectorized execution, column storage, very high compression and codecs, interesting functions that allow us to do analytic queries, and the ability to scale to many petabytes. ClickHouse is open source, released under the Apache 2.0 license, so that's a little bit different from MySQL. And the first thing that people really notice when they come in, aside from the fact that it talks SQL, so it's kind of familiar, is it's extremely fast. We do a number of webinars on that subject. If you're interested in more detail about how you can make ClickHouse fast, have a look at our previous webinars, for example, on performance or materialized views. You'll find lots of information there. What I'd like to do now is talk a little bit about MySQL. So MySQL is a great database. I've personally worked with it for about 15 years and wrote software for it for a good proportion of that time. If we compare it to ClickHouse, we see some major differences. The first thing is that MySQL has a relatively complete SQL implementation, which includes not just selects, but the ability to do update, insert, update, delete, plus the ability to have roles, many, many features that people expect when they're running a transactional store. So that's an important difference, whereas ClickHouse is optimized for doing analytics. Another major difference, which becomes very important when we talk about performance, is that MySQL stores data in rows. So what that means is that if you're doing a table scan, you will read the data for every single row in the table. This is an enormous amount of data compared to the way a column store operates, where we only read the data for the columns that were asked for in the query. Moreover, we're very selective about how much of that data that we actually read. Another big difference is that MySQL is by and large single-threaded. There is emerging parallel query. For example, if you go to Aurora, that's a feature of that database, and some beginnings of it in the most recent SQL releases. But this overall is a major difference and has an enormous impact on how fast you can do queries. Where MySQL scales very well is on very high transaction loads. For example, it's not uncommon for a properly configured single MySQL query instance to be able to handle on the order of 1 million queries per second. It's enormously scalable for small, highly concurrent queries. And so that's really the sweet spot that we see when you're building MySQL. If you need to have a very fast transaction processing for small transactions, if you need to make a lot of point queries, MySQL is a great solution. And as we look at the MySQL structure, one of the things we see, of course, is the rows. The tables are arranged in rows. Use a B-tree index to find the data. So it's a quite different organization under the covers from ClickHouse. Now, that difference in organization brings some very, very large trade-offs if you're operating MySQL, and particularly if you have a MySQL database that ends up accumulating a lot of data. As I've mentioned, having this row organization creates an enormous I/O load when we scan the table. Moreover, as your tables become large, and even when they're small, in order to ensure query performance, you actually have to put a lot of indexes on the table just to be able to find things. MySQL is not fast if it has to do a table scan, for example, down a single column to find relevant values. Compression is of somewhat limited value in many situations, so you can reduce the amount of data, but for analytic queries, it tends to be kind of a wash in terms of performance. Moreover, as I've mentioned, parallel query is limited. And finally, when you're operating MySQL, your performance is extremely dependent on whether your data can fit into the InnoDB buffer pool. The result is that for any table that has more than, say, 100 million rows, MySQL particularly, it can be very, very slow, especially if you have to do table scans. So one of the options, and this is really the theme of this talk, is to look at ways that you can use ClickHouse to get your analytic queries done and extend the capabilities that you have in MySQL. There are many ways that you can do this, and this table this talk is going to give you enough integration about the integration that's available between ClickHouse and MySQL that you can figure out which of these scenarios is best for you. But two examples of how you can approach this is that one is that if you have a MySQL database or multiple MySQL databases that have some very large tables. For example, it's not uncommon in MySQL applications to have a couple of tables that are essentially fact tables. They're recording like clicks on emails, for example, if you have a marketing application. You can just take those single tables and you can move them lock, stock, and barrel to ClickHouse and keep your dimensions in MySQL. Another thing you can do is, and that we see quite commonly, is that people are actually using MySQL as the analytic database. So, for example, crunching information that supplies dashboards. In this case, where MySQL really is the underlying analytic store, you can just go ahead and take the data and move it lock, stock, and barrel completely to ClickHouse and just drop MySQL completely. Other combinations are possible, and you'll see possibilities as this talk goes along. So at this point, what I'd like to do is talk about the first kind of integration that's available from ClickHouse, and that is accessing MySQL data directly from inside ClickHouse. It turns out that ClickHouse has some really great ways to do this. So let's start with a sample. I've created some very simple sample data that we can use to play around with. I have a traffic table that's recording, for example, requests that are appearing on a website. I have a customer. It has customer ID, so we track the customer, we track the product SKU that they're looking at, and those are in a couple of dependent or tables linked by foreign keys. So this is a pretty typical setup in MySQL, and sort of nice third normal form and everything like that. If we're in ClickHouse, there's a number of ways that we can access that data without actually even moving it out of MySQL. And I'd like to explore these now. So they include what's called a MySQL database engine, where we can see an entire MySQL database, a table function, where we can have an expression inside a ClickHouse query that returns query results from a MySQL table. We can also have a table engine, which defines the table and makes it appear as an ordinary table inside ClickHouse. And finally, we have what are called dictionaries, which are basically hash tables that suck data out of a MySQL database and hold it in cache on the ClickHouse side. We'll explore all of these because they're very effective ways of integrating data. Let's go ahead and look at the MySQL database engine. Oh, excuse me, forgot one thing. So just as an example, here's how we select all the data from all three tables in MySQL. So we're going to select the core data from the traffic table, and then we're actually going to translate the customer and the SKU name so that there's something human readable. The way we do this in MySQL is we select from the traffic table, and then we have a couple of joins on the dependent tables. I've just limited it to 10 because we have about 10,000 rows. This just makes sure that we don't show all the data in the window, but it doesn't really affect what comes back. So this is how you do it in MySQL. And what we'll do in these examples is we'll show you how to do the same thing from ClickHouse in various ways. So let's look at the setting up the MySQL database engine. So this is actually really simple to do. What you're going to do is issue a create database command in ClickHouse, and for the engine, which is normally you don't say anything, and then it's a proper ClickHouse database with local data. But in this case, we're going to give an engine, and this engine function takes some parameters, which, as you can see, are the location of the MySQL server, the database that we're going to be talking to, and the credentials that allow us to get into that database. So if we issue this command, we can then actually go ahead and use that database and start looking at and playing around with the tables. Rather than do a bunch more slides, I'm actually going to demo this because it's quite simple. So let's go ahead and bring up our ClickHouse client. So I'm right now using the ClickHouse client in the window in black. Let's slide that over just a hair so that it's easier to see. 1 second. There we go. Okay, so let's go ahead and use the database that we've created, so MySQL REPL. And I do a show tables. This is the database that was just created by that command that we showed in the slides. So we'll do a show tables, and there we have our MySQL tables, which are just sitting there and now visible through an ordinary ClickHouse show tables command. Let me demonstrate that this is really looking at MySQL. So here I have in the yellow screen, I've actually got the MySQL client up and running, and we're going to use the REPL database that we're connected to. So let's go ahead and use REPL, do a show tables. Same tables are over here, and now what I'm going to do is just create a dummy table. So we'll go ahead and create table foo, and just with a single column, we create the table. And now what we can do is we can come back over to ClickHouse, and we can do a show tables, and that table foo instantly appears. So ClickHouse picks this up as soon as you do the show tables or refer to any table there. Moreover, I could go ahead and add data and select off it. I'm not going to bother to do that, but I will show you that I can immediately select off this data. Oops, don't need a semicolon because I'm over in ClickHouse. So there I can select off the table. Moreover, I can do larger selects. And in fact, what I'd like to do is just go ahead and illustrate that same select command that we used that I showed to select the data from MySQL. We're going to go ahead and just issue that command right here in ClickHouse, and there we see the data. So what we're doing is we've moved no data over to ClickHouse, but we're just looking directly at the, through this MySQL table engine, we're able to connect to MySQL and issue queries on the data there. So this is a pretty powerful capability. Let's pop back to the slides because I have this capability actually has a rather interesting surprise that I'd like to share with you. So let me get our slides. So looking back at the slides again, here's an example of a similar query to what we just issued. And one of the things I should point out is that ClickHouse is at least moderately intelligent when it does these queries. So for example, if I put a condition on here, for example, where customer ID equals 5 to filter the data, that predicate is actually going to get pushed down into MySQL itself. So we won't ask for data as we're selecting from the main traffic table. We're not going to ask for data that does not match this predicate. And I'll show you later on how we can prove that that's actually what's going on. There's an even more interesting capability, though, which is quite surprising, and that is that for large tables, ClickHouse performance is actually faster than MySQL on data resident in MySQL. So this can be very surprising. These are examples that are taken from a recent blog article on the Altinity blog. But what's happening here is that we have a relatively large table and we're running group bys on that, which is an operation that that ClickHouse does very, very efficiently. So when we run the query in MySQL, for example, looking at the third line, one of these group bys takes something like 212 seconds. However, when we run it in ClickHouse, it only takes 5 seconds. And the reason for that is that ClickHouse, even when it's accessing MySQL data, accesses it in parallel. So the same types of parallel query using multiple threads, which we do when we're using ClickHouse on native data, for example, in merge tree, those same techniques are used on MySQL. So what you in effect have is parallel query on your MySQL data. This is really interesting. Now, it doesn't work this way in every single case, and we can also see that as we read across, moving the data fully over to MySQL results in an even greater speed up, of course. But this is a really interesting capability that if you wanted to accelerate the queries, one way is just to stand up a ClickHouse database, and for large tables, there's a good chance that you'll already have much better query performance. Now, what I'd like to do is sort of continuing to work through this example. What we could do is we could actually just move all the data from that big table over into ClickHouse. And that's really easy to do because we have the database engine, which allows us to see the data. What we're now going to do is actually create an equivalent table in ClickHouse. And it's actually fairly easy to do this because one of the nice things about the database engine is it will translate the data types and create a pretty good representation of your table that you can then access from ClickHouse. And what that means is that if we want to create our own version of this, we can do a create table command, set the engine to be merge tree, do a partition by, and actually this command, just one second. Okay, what's happening right here is this command is slightly misleading. That should say MySQL REPL.traffic. But what we're doing here, there was a typo in this command. What we're doing is creating a table from the column definitions that were available in the MySQL REPL database, and then just applying the normal parameters to create a merge tree table. So a partition by, sort of partition key, as well as an order by, which will give us our indexing and sorting. At that point, you can go ahead and just pull the data straight into MySQL. So here we do a select, and we're basically going to insert that into our new traffic table. And if you then do a count on that, you'll see that there are 10,000 rows. So that's really straightforward if you want to move data. If you want to move a large amount of data, of course, it'll take a little while. I'll show you some techniques for how to do that in just a minute. Now, that shows you how we can access data through the database engine. We can also move data in, as we wish, over into local tables fairly easily on ClickHouse. Let's look at some of the other ways that ClickHouse allows us to integrate with with MySQL tables. So the next thing that we can use is what's called a table function. So a table function is basically a function that returns tabular results, and you can use it anywhere that you can put a table name. So for example, I'm going to take that same query, and I'm just going to do one join here. I'm going to just do part of it. But I'll select the base table information, and then I'm going to translate the customer name to the full name. And in this case, instead of selecting from a table name, I'm going to give this function where I have the location of the server, the database, and then my the table name as well as my credentials. And this allows me to basically select from that table. I can even put conditions on this, which are sort of interesting. So in this case, I'm actually putting a predicate on here where customer ID equals 5. And what is kind of interesting is that will get pushed down. Depending on how you structure the query, sometimes it will only push it down for the base table in the join, like the left side table. Sometimes it'll do it for the other one. You need to test it out. But this basically gives us the same information as we got before. The difference is that we're just using a table function. So that's an option that you can do. And the reason table functions are handy is you don't have to set up table definitions. You can just use them on the fly. We can go ahead and turn this, instead of using a table function, we can just turn this into a freestanding table. The command is relatively straightforward. You just do a create table, give it a name, give the data types, and then you can give the engine. In this case, it's a MySQL table engine, and it looks very similar to what we did with the MySQL table function, location of server, where's the table, and then credentials to get it. This command is actually kind of handy because one of the things it allows us to do is to go ahead and play games with, for example, if we need to vary the data types, if the automatic generation in the ClickHouse database didn't quite get it right, we can basically fix that. We can also allow the table to live anywhere that we want in any database. And in that case, as soon as that table comes over, then you can do joins on it just as if it looks like an ordinary table. ClickHouse at the SQL level can't really tell the difference. So there is a fourth way to get at MySQL data, and that is to use a dictionary. So a dictionary is, for those who've not used it, is basically a hash map that contains values corresponding to a dimension table that is located in some other place. So the tables can be in files, they can be in ClickHouse itself. In this case, and in the example I'm showing, the dictionary is actually being loaded from MySQL. So we give source information, and what you see here is an XML file that you fill out. You just pop it into the etc ClickHouse server directory, and then ClickHouse will automatically recognize it and go ahead, assuming that your syntax is correct, it will go ahead and allow you to reference this dictionary and pull data from it. So in this case, dictionaries are a little bit cumbersome because of the way they have to be defined in XML. We give a structure which includes an ID field, which must, as it turns out, in the version I'm using, must be UN64. And then attributes. In this case, it's a very simple table. It just has name. So we give this definition, and then at that point, we can begin to select from that data as well. And here's an example of that original query that I started out with, where we're doing joins on 3 tables using a subquery in ClickHouse. I've now adopted it so that I'm now reading from the base table. I'm joining on the customer table, which was defined as MySQL customer. And finally, I'm using the dictionary to look up dictionary values from the 3rd table containing SKUs. So these are, this example kind of rolls together then all the different, or a number of the different ways that you can connect to MySQL. So you now have these tools that you can use to access the MySQL data in whatever way is most convenient for you. So it's worth, one question that does happen is that when you're doing this kind of query, under the covers, what's happening is, of course, the table engine is receiving the parsed query, which is in the form of an abstract syntax tree, and it's doing a translation to make sure that, to translate to an appropriate, something appropriate for MySQL. So if you do use this for example, if you're thinking about deploying or you want to see, understand the behavior in more detail, one thing I highly recommend is that you go ahead and turn on the MySQL general query log. So the option to do this is shown up above. This turns the query log on dynamically. And what you can now do is if you run those same queries that we had as examples, you'll now begin to see that what's actually happening under the covers in MySQL. And I'm just showing one example that I ran just to confirm that we get predicate pushdown. So what's happening is this was a query on the ClickHouse side. There was a filter condition on the SKU table. And what we can see is this is actually the query on that last line that ended up landing in MySQL, so that MySQL will only send back data that matches the filter condition. So you can use this as a way of, if MySQL, for example, isn't doing quite what you expect, or if you want to understand what's the performance impact and help optimize it, looking at the query log is a great way to do that. So with that, we're basically past the integration from ClickHouse back to MySQL. What I'd like to look at now is a question of how do we actually propagate, if we're moving data over to ClickHouse to work on it, how do we actually handle the question of propagating the base table as well as changes? So that's important because MySQL, of course, is going to be running, it's going to be processing transactions, and as those transactions are processed, any data that's relevant that needs to go over to MySQL, we'd like it to come over as efficiently and as simply as possible. So that's where we get into looking at ways to replicate MySQL data into ClickHouse. I'm going to talk about three options here. I'm going to demonstrate one of them, but they include selecting directly from the MySQL tables. You just saw, I showed you a slide that demonstrates how that happens, and I'll extend that a little bit so that we can pick up, propagate new changes. We'll also talk about how to use row replication. We have a project which can actually move data automatically through replication, so I'm going to go ahead and talk about that and actually give you a demo. And then finally, we'll discuss use of Kafka, which is, of course, a very common way to move data in large amounts at high speed in many companies. So let's look at the select trick. So this is really very simple. What we'd like to do is not just select the base data. I showed you in a slide how you can do that. That's very simple to do. But we want to select the base data, and then at intervals, we want to select any data that has accumulated since then. So this is actually relatively straightforward to do, provided your table has a key that is in some, or has some value that is monotonically increasing, and you can use to track progress in the table. So in the case of the traffic table, we have a field called request ID, and that is incremented by 1 every time we get a new request. So so if you have something like that, or if you have a timestamp that you can trust, you can use that in order to select data and bring it across. So what we do is we create a table on the MySQL side, which has the last request ID. And then what I'm going to do in this particular example is I'm just going to insert a value into it, which is -1. And I can do this, the insertion I can actually do from the ClickHouse side. It turns out we can actually insert. But this is now going to allow us to track how much of that big table we've read. So in this particular case, what we then do is you just have a little script which executes 2 commands. So we have the traffic table that we want to propagate data into, and we're going to run an insert into that table, which is a select from the the traffic table that we can see through in this case, through the MySQL database engine, and we're basically just going to look for everything where that request ID is greater than the request ID in that last request ID table. And the fact that we can join and see the data makes this very easy to do. So what this will do is if the first time we read the request ID, the first value is 0, so it's basically going to select everything in the table. And then what we'll do after that is we'll go ahead and say, okay, what was the max thing that we got? We will go ahead and put that value, just append that value into the request ID table. And as we repeat this, what we're going to do each time is we'll look for the maximum value that's been stored in that little last request ID table, and we'll select everything that's above it. So you can just do this again and again and again. This is a very simple way of replicating data from a table into ClickHouse. It doesn't require any special setup. You will, of course, have to play around with it to make sure that the performance is adequate. You'll want to do things as a cron job, so on and so forth, but very straightforward to do. Now, if you have larger amounts of data or you want things to be more automated, another option is to leverage MySQL replication. So, as most people on this call are probably aware, MySQL replication automatically replicates data, or enables you to automatically replicate data from a master database to a slave database. And this happens through what's called a bin log. So when we use this technique, we're going to need to do three things. First, we're going to make sure that all of our MySQL tables that we plan to replicate have primary keys. This is a requirement for using MySQL replication, and it allows MySQL to be sure, for row replication, allows it to be sure that of the value that it's propagated and correctly insert it into the target. The next thing we'll have to do is actually enable row replication itself. So you go to my.cnf, and the key thing here is, actually we don't, it doesn't show it on, but these are some of the settings, and a key one is to have the bin log format equal to row, which means that when we're writing stuff into the bin log, we don't write it as SQL statements. We actually write it as an array of row values. And then the third thing is we're going to need to run a program that can actually read out of the bin log and propagate those values across automatically and apply them to the table in ClickHouse. And we've actually written a project called called ClickHouse MySQL, which is available on the Altinity GitHub, that does exactly that. Not only that, it's pretty smart about fetching the original table as well. So what I'd like to do, rather than drawing a bunch of pictures about how that really works, is I'm going to go ahead and demo it. So what we're going to do here is we will go ahead and do a little bit of setup. So on the MySQL side, I'm going to go ahead and refresh all those tables that we had. So we're going to go ahead and quit out of here. We're running a script here that just set up those tables I was looking at in the REPL database, including our last request ID table, which is set to -1. So we now have MySQL data. Now, what we'd like to do is go ahead and log into MySQL and confirm that replication looks like it's running. So let's go ahead and log in, and we're going to go ahead and look at our variables to check that our configuration is correct. So this is necessary to ensure that, because like the worst thing, one of the things you don't want to do is actually do a bunch of setup and then it turns out the replication is not correctly set up. So here we have bin log format as row, so we're correctly using row replication. Replication is enabled. Here's the base name of the files that are used for the MySQL bin log files. The rest of these parameters are not so important, and we can forget about them for now. So replication is now correctly set up. So on the ClickHouse side, we now need to create a target table. So let's go ahead and I think we have a REPL database here that we're going to use as our target. Show tables. No tables there. So in this case, we're going to go ahead and create a target table explicitly. So I'm going to go ahead and set that up. So target table. All right, it's created. And at this point, I've got a target table. It's empty. I've got data on the MySQL side. I'm now going to start our program, which is the ClickHouse MySQL program, which is now going to dump the data over into ClickHouse, and it's also going to start listening to the bin log, and it'll pick up any additional changes. So let's go ahead and do that. We'll go ahead and run that. I put it in a script because it has a bunch of parameters, but what it's doing is it's going ahead and it's actually propagating all the data, and it's listening at the bin log. So now what I'm going to do is let's go ahead, in that table which we just created, we put no data in it on the ClickHouse side. Let's prove that there's data in it. So there it is. We've got, interesting. So I have some extra data in this. That's more than I expected, but no problem. What we'll do is go ahead and actually create some data in MySQL. And in this particular case, what I'd like to do is add some additional information to the table and then just prove that we see the data appear. Just once. Up. Looks like it's too far back. 1 second. Let me get the. So we'll go ahead and add some data. And now we'll repeat our count. And what we see is that count, I inserted on the MySQL side, count goes to 20,001. Now what I'd like to do is go ahead and insert another one, give it another transaction ID. Again, it's going to get picked up automatically, and we expect to see our count go to 20,002, and that's exactly what happens. So this is an example of using replication through this this tool that we've developed to actually automatically pick up the data coming from MySQL. So that's the demo. We can go back to our slides now and talk a little bit about sort of another way of replicating data. One thing I should point out is if you'd like to use this ClickHouse MySQL command, go ahead and pull it from our GitHub. We also put it up on pypy.org. It is a Python program. One limitation of this program is it currently only handles inserts. So for example, if you do an update, it won't know what to do with it because when we're sending this to a merge tree table, we don't actually have a convenient way of representing the updates. So updates and deletes are not currently handled, but if somebody needs that, we can suggest some ways that can be done. So with that, let me talk about a final way of replicating data. And this is using Kafka. So if you're just replicating from a single MySQL server, using a point-to-point solution that reads the bin log and applies to ClickHouse makes sense. But let's say you have 100 servers, or even a dozen. At that point, maintaining a tool that looks at the bin log from each of these and replicates the data across correctly can be really cumbersome to manage. So in that case, what's simpler and better in terms of management is to use a technique where you're actually going to extract the data from the bin log, and instead of sending it directly to ClickHouse, you put it into Kafka. And there's at least a couple of tools out there that can be used to read the bin log and put it into Kafka, and some of you may be using these already for other reasons. But then what you do on the ClickHouse side is you actually configure ClickHouse using the Kafka table type to read out of the queue and actually read the data as it's coming off and stick it in the table. And the cool thing about this is it means that as you add more servers, you just configure them to write to Kafka, and then ClickHouse will automatically pick up the data. So describing the configuration of this is a little bit outside the topic or outside the scope of this talk. We may do a webinar on it at a later date. But meanwhile, if you're a MySQL user and a Kafka user, you can probably figure out how to put this together. So with that, I'd just like to leave you with a few bits of a few thoughts on how to manage this problem of propagating changes. So first is that one of the things you really have to think about is, as a MySQL user, you're used to dealing with tables in third normal form. So that is to say you might have a fact table, but then you'd have a lot of dimension tables, and then you will join on them. That's not really the best way for ClickHouse to work. What's typically better is just to have a very wide table where all the data that you're planning to to use is already in that table in a denormalized form. So one of the things you can do is if you are propagating data out, you could consider, for example, using a trigger which collects the current dimension info, adds it to a table that's set up for transfer, and then that's the table that you replicate. And then what will land over on ClickHouse is data that has sort of fully formed wide rows that you can then easily run queries on. Another thing that I should point out, and this is just a sort of a warning, is that replication methods are somewhat complex to operate. I wrote a replication for something called Tungsten Replicator, which actually still exists and may add support for replication into ClickHouse in the very near future. But setting these things up and managing them does require some work. So it's something to take into consideration. You can reduce the management a little bit by using Kafka, but that of course brings its own management complexities. So overall, if you can do it, the best way to do this is simply to take those large tables that you're working with and just put them in ClickHouse. So if you have an application that is really generating a fact table inside MySQL, just have your application stop writing that to MySQL and instead write it directly to ClickHouse. And that will make MySQL run faster because you have less, you don't have these large tables that are polluting your buffer pool. There's also no replication to manage because because ClickHouse becomes a system of record. So this is, as you're thinking about this, look for something that makes the resulting system as simple as possible. And the closer you can get to full migration, the easier it is to manage. I'd like to talk about one more topic, which is kind of a surprising one, and that is that ClickHouse actually will very happily support MySQL clients. So this is a new feature. It's somewhat experimental, so you're likely to find, for example, if you use if you use parameterized queries or something like that, you may discover some surprises. But you can enable the wire protocol simply by going into the config.xml in ClickHouse and enabling this MySQL port tag and giving it a port name. That's all you have to do. Restart ClickHouse, and it now talks to MySQL wire protocol. And so what you can do is you can then log in using, for example, the MySQL client. Other clients will work as well. Go ahead and use the database. At this point, you're using the MySQL client, but you're talking the ClickHouse dialect. There's no translation, so you have to get the SQL syntax correct. But this does allow a MySQL, if you don't want to have add additional libraries, things like that, this does allow apps to go ahead and talk directly to ClickHouse. There is a tool out there that in the past has also helped with this. It's called MySQL Proxy. But I tested it out recently, and it seems that they had support for allowing clients to log into ClickHouse using the MySQL wire protocol and also automatically translating at least some of the MySQL dialect to ClickHouse. But it appears that in the latest builds that capability has been pulled out, so I don't think it's supported anymore. And at this point we can't recommend it because it doesn't seem to be in the standard version. So that's about it. Those are 3 different ways that you can integrate ClickHouse to MySQL. So, and I think what's impressive, this is something that I've come to use and to learn how it works. And I think what's really impressive is how many ways there really are to access the data from ClickHouse to MySQL, to get data from MySQL to ClickHouse, and then just to have the apps talk to ClickHouse as if they were talking to MySQL. And there's continued work on this in the community, so you can expect to see this improve over time. So you can use those multiple ways to support whatever access pattern you want, starting with just leave the data in MySQL and let ClickHouse run parallel query on it. That's an interesting and quick way that may give you a big gain for not a lot of pain. You can use replication pull changes if you have to. You can use the MySQL protocol. And then overall, keep that approach as simple as possible, because that's going to maximize the benefit and reduce the pain for administration. So keep it simple. And with that, our webinar is complete. I want to say that I just want to let you know that we do have a special offer. If you're interested in this or any other ClickHouse topic, we are happy to do a 1-hour consultation to help you work through it and figure out also ways that we could potentially be of assistance to you in making your ClickHouse applications work better. So contact information is up above. One thing I'd like to do is go ahead and ask you, for those of you who have patiently listened to this, go ahead and let's start the poll. So you should see a poll popping up, and if you would be so kind as to fill this out, that will help us do better webinars in the future, including understanding what our audience is, what level you're at, how did you like the technical content, and of course, what are new things about ClickHouse that you would like to hear about in these webinars. So if you'll go ahead and fill that out, I will go and answer questions. Oh, great, I've got a couple here. All right, are there any plans to support mixed bin log format for the MySQL replication stuff? Yeah, that's a really tricky question. So the problem is that if mixed bin log, so in theory it would work, except that for the tool that we've written, it really only can make sense of inserts and only in row format. If you had a case where things actually turned out to be a statement, we wouldn't know what to do with it very easily. So that's so at this time, we're really only focused on supporting row replication, and in general, based on my own experience at least, when writing replication products, that's really the only way that you can sort of reliably support moving data out of MySQL into non-MySQL data sources. You really have to have row format. Moreover, in many cases, you need to have full rows. You can't use partial rows or any of the tweaks that MySQL uses when it's communicating between MySQL instances. So there's definitely some restrictions there. So does the wire protocol mean that we can use MySQL stored procedures run on ClickHouse tables? The answer is no. And here's what's going on. Because when you're using the wire protocol is just the transport that gets your SQL statement from the MySQL client, or whatever your client is, over to ClickHouse, and then sends you results back in a form that a MySQL client can read. It doesn't actually do anything with the SQL. So the SQL that you actually send, and if we go back to that, that particular case, the SQL that you send is going to have to be the ClickHouse dialect. So as I say, there was this nice sort of emerging tool, MySQL Proxy, which was translating, but that doesn't seem to support us anymore. Are there plans to implement, here's another great one, plans to implement Postgres Engine? There already is some Postgres support. I haven't used it, but I think there's table functions and table engines. Somebody have to correct me on that. I'm not looking at the docs right now. There isn't a Postgres database. I do not know if there is a PR for that. I actually just haven't looked at the topic very much, but I would guess that people are thinking about that. And in fact, one of the first thoughts I had when I was preparing this webinar is like, wouldn't it be nice to have the same level of support for Postgres? I don't see a reason why that wouldn't be the case. The reason that we have good MySQL support is it just happens that a number of the committers in the community also work on MySQL integrations, so that's why we get that stuff put in. Another question, does ClickHouse work with MariaDB? I have not personally tested it, but it should. So to the extent that that the wire protocol is identical, and generally it is, as long as we're not doing something that triggers one of the few differences in this area, MariaDB should work just fine. So definitely test it, but I do not know of any reason why it would not work. So great. If there are any further, these are wonderful questions. Thank you so much. If there are any further questions, I'll stick around for a few more, for like a minute more if you'd like to think of anything else? Okay. Okay. So, of course, I was asking if it's possible to declare a stored procedure in MySQL using ClickHouse dialect. The answer on that is no. You can't mix these two things. You're either talking to MySQL or you're talking to ClickHouse. You're not really talking to both. But I think you are sort of headed in a direction that we think is really interesting, which is just figure out ways that we can use ClickHouse to accelerate processing of data on MySQL. If you have additional ideas on that or particular needs, feel free to contact us. We'd love to talk to you about it. Let's see. If we move the table into ClickHouse completely, this is a great question. Is the row-intensive query will it still be performant? The answer there is no, and or less performant. And the reason is that if you're familiar with ClickHouse, one of the big differences between, of course, between MySQL and ClickHouse is in MySQL, if you read a row, the most you're going to read is the blocks from InnoDB that contain that row. So it's a relatively small amount of data. It comes quickly in. In fact, there's a good chance if you're looking at the same row a bunch of different times, it's already present in the InnoDB buffer pool, and you're reading it straight from memory. ClickHouse is different. ClickHouse, by default, if you're using merge tree, will read data from up to 8,192 rows when you ask for a single row. And the reason for that is we have a sparse index, which only has entries for every 8,192 rows. And then we read chunks of data that correspond to that gap of 8,000 plus rows. Now, ClickHouse is often still more performant than MySQL even in that case, because it will read, if you have a lot of columns, it will only read the columns that it needs, and the compression is really efficient, and ClickHouse can use parallel query. But if you have the things that you would lose is the ability to do, for example, a lot of highly concurrent point queries. That's definitely different. So I hope that that makes sense. Let's see. Here's a question. We're implementing ClickHouse for our log database for auditing purposes. In MySQL, the data is too large. We can't scale anymore. In ClickHouse, it's about 12 times more compressed. We loved it, but how reliable is that? If it gets corrupted, are the tools for recovering? We've been using MySQL for decades, but we're completely new to ClickHouse. Great question. Okay, so here's the kind of thing that there's a couple of differences here that you need to be aware of. So one is that ClickHouse can get a little bit confused sometimes, but only if you have, there's ways you can set up ClickHouse, for example, if you have very high levels of inserts, if you use materialized views. ClickHouse doesn't guarantee transactional consistency between different copies of things the way that MySQL does. So there are very occasionally cases where if you have a table, you have a bunch of materialized views, you lose a little bit of, you have a failure while you're halfway through updating them, you can get cases where you'll get partial data and you need to resubmit, and so you may end up getting things twice. That's a fact of life in ClickHouse. It's an edge case for most people. I rarely hear about it happening, but it is possible. Whereas in using InnoDB, if you have everything done in transactions, don't use auto commit, you can have things be completely consistent, and InnoDB very, very rarely loses data. On the bigger issue of like what happens if you lose a node, which is far more likely, ClickHouse actually has a really great solution to that, which is baked in, batteries included replication. So ClickHouse replication in general is easier to operate, in fact, by quite a bit, than MySQL. So most people will set up replication if they're concerned about losing data, and then they'll depend on that to serve HA purposes. There are also ways to, and so that will deal with things like storage corruption or losing an instance. So that's pretty much the standard answer that we would give on that. And if you want more detail, we'd be happy to talk to you about it. Okay, these have been great questions. So I would like to thank everybody for attending. We're going to go ahead and close up. We hope this webinar was useful. Thank you so much for filling out the the votes. We'll definitely be looking at this in future webinars, and we hope to see you in the near future. So thank you very much. Have a great day, and it's been great to present to you. Bye-bye.